Hi folks, we're going to take a look at number 34 from page 560. So I drew a picture of the scenario. So they basically tell us that there's a 400 kilogram box on a ramp that's 30 degrees from the horizontal, and they want us to find the components of the force due to gravity, both horizontal and perpendicular to the ramp. Okay, so here you got to think that if we let that dot represent the 400 kilogram box. Okay, we've got the force due to gravity, which goes straight down, of course. Okay, and the magnitude of the force due to gravity, of course, is just going to be 400 times 9.8. Okay, so let's calculate that. 400 times 9.8 is 3920. Okay, so what we're looking for is we're looking to break this force up into perpendicular components. Okay, one that's parallel to the ramp. I think I said horizontal before, I meant parallel to the ramp. Okay, so that would be force in this direction, and then a force that's perpendicular to the ramp. So I'm going to draw it as adding these two vectors tip to tail. So if I add this parallel component plus this perpendicular component, that's going to give me this force due to gravity. Okay, so what I have here is, because these two forces are perpendicular to each other, I create a right angle triangle. Okay, now we've done the geometry to show that if this ramp has an angle of 30 degrees, that this angle inside the triangle there is also going to be 30 degrees. Okay, and now we have enough information to find the components of these forces, because we have the hypotenuse of this triangle plus an angle inside the triangle. Okay, so let's start with the force that's parallel to the ramp. Okay, so here we'll use sine for that. So we have sine of 30 is equal to the force which is parallel to the ramp over the hypotenuse, which we calculated was 3920. So the force, okay, and this is of course just the magnitude of the force parallel to the ramp, is going to be, well, we have this 3920 already there, so times sine 30. Okay, so 1960, so 1960 newtons. And then similarly for the component of the force that's perpendicular to the ramp, we're just going to use cosine. So we have cosine of 30 degrees is equal to the magnitude of the force perpendicular to the ramp over the hypotenuse, which is 3920. So F perpendicular is just going to be 3920 times cos of 30 degrees. Okay, so that's about 3395. Okay, and that's it. That's what we were looking for. So step number one was to get a good diagram, okay, and to realize that the force due to gravity just goes straight down, but we wanted to break this force apart into one that was parallel to the ramp and one that was perpendicular to the ramp, creating this right angle triangle. And so we could just use regular trigonometry to solve this problem. Okay, that's it for this one.